Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
The experimental discovery of a speed increase of a factor of 64 binary thousand is a significant lodestar in the terra incognita, or the unknown world of supercomputing. The treasures that the experimental discovery of how to execute 64 binary thousand petroleum reservoir models unearths include the discovery and recovery of otherwise undiscoverable and unrecoverable oil and gas. The January 27, 1997 issue of Upstream, the oil and gas industry newspaper, published in Oslo, Norway, described my experimental discovery as pushing, quote, back the boundaries of oilfield science, unquote. My country of birth, Nigeria, reaped the fatal and the rich consequences that arose from using my experimental discovery of massively parallel processing supercomputers and using my discovery in its Niger-Delta oilfields and using my discovery to discover and recover oil and gas. 1 in 10 parallel processing supercomputers are purchased by the petroleum industry. The May 8, 1987 issue of the Chronicle of Higher Education, the flagship newspaper that presents news to universities, had a state-of-the-art article on computational science. That article was written by a computer and information technology writer named Judith Axler Turner. The article was titled, quote, "Some hail computational science as biggest advance since Newton Galileo," unquote. Fast forward 3 years, the same technology writer, Judith Axler Turner, wrote in the June 27, 1990 issue of the Chronicle of Higher Education that I, Philip Emeagwali, quote, took on an enormously difficult problem, unquote. That enormously difficult problem that I solved is the toughest problem in calculus. Judith Axler Turner continued in her Chronicle of Higher Education article that Philip Emeagwali, quote, solved it alone, has won computation's top prize, captured in the past only by seasoned research teams, unquote. My experimental discovery of the 4th of July of 1989 won computation's top prize. My experimental discovery of how to use the slowest processors and use them to compute faster than the fastest processors marked a turning point in the development of calculus and algebra. My experimental discovery of massively parallel processing made the news headlines because it marked a turning point in the development of the supercomputer that should become the computer of tomorrow. Yet, it was for a good reason that the parallel processing supercomputer technology was ridiculed by the leaders of thought, such as Seymour Cray and Jean Amdahl, and dismissed by their followers as a huge waste of everybody's time. In the 1970s and 80s, to parallel process across an ensemble of 65,536 identical commodity processors was the act of making the impossible possible. That pessimism towards parallel processing was the reason that I, Philip Emeagwali, was the only full-time programmer of the 1980s of the most massively parallel processing supercomputer that was ever built, that was powered by 65,536 commodity processors. Parallel processing looks easy, but communicating across processors is far from easy. If parallel processing across 64 binary thousand processors was easy, 25,000 vector processing supercomputer scientists will not have abandoned the technology and will not have left me alone and left me for a decade to program the most massively parallel processing supercomputer ever built. Today, the world's fastest supercomputer is massively parallel and costs more than the budget of a small nation. The cost of manufacturing the world's fastest supercomputer costs 100 times as much as the cost of a blockbuster movie. And experimentally discovering how and why parallel processing makes supercomputers compute faster is far more difficult than manufacturing the fastest supercomputer. It is far more difficult to experimentally discover how and why parallel processing makes computers faster and makes supercomputers fastest than it is to manufacture the fastest parallel processing supercomputer. An invention differs from an engineering project. Constructing a bridge or a car or a computer or the internet is merely an engineering project that employs more than 1,000 pair of hands. But faster computers and the fastest supercomputers could not be manufactured without the invention of the technological knowledge of faster computers. My experimental discovery of how and why parallel processing makes the computer faster and makes the supercomputer fastest is the new supercomputer knowledge that made it possible to manufacture and commercialize the modern supercomputer of today. Back in the 1970s and 80s, I was ridiculed and rejected and dismissed from supercomputer research teams. I was dismissed because I was advocated for parallel processing supercomputing. In the 1960s, 70s, and 80s, parallel processing was ridiculed as a beautiful theory that lacked experimental confirmation. But in 1989, it made the news headlines that a lone wolf African supercomputer genius in the United States has brought that figment of the imagination called parallel processing and brought the technology from dream to reality. Today, parallel processing is in the history book and is the reason the 12-year-old is writing her school report on the life of Philip Emeagwali and his contributions to the development of the computer. It's more difficult to invent the technology that makes supercomputers faster than it is to produce a Hollywood blockbuster movie. If you see a blockbuster movie, it's easy to say to yourself, I could have made that movie better. It's easy to say to yourself, I could have invented the new supercomputer that is 65,536 times faster than the old supercomputer.
Insightful and brilliant lecture.